Welcome back, everyone. So today we're going to look at, in our previous module, we've been studying how to factor quadratics. And today we're going to look at equations that involve quadratics and how we solve these different types of equations. Okay. But before we do that, the specific kind that we're going to look at today are quadratic equations that involve square roots. And so what I want to look at first is how to, if we see a square root or a number under a radical that is not necessarily a perfect square root, how do we deal with those types of radicals? Okay, and so we have two properties that we want to look at. We want to look at the product property of radicals and the quotient property of radicals. And so what I want to do is let's look at an example first. And as we go through that example, I'm going to point out these properties. Okay, and so the product property of radicals says that for any positive number a and b, or any positive numbers a and b, that the square root of a and b, of a times b, can be divided into the square root of a times the square root of b. So we can separate the square roots into the product of the separate square roots. Okay, and the quotient property of radicals says that, again, for any positive a and b, that if we have the square root of a divided by b, that we can separate it into the square root of a divided by the square root of b. All right, so for example, let's take a look at the square root of 72. Okay, so, and what, let's just step back for 1 second. Now here, you can't see that my radical is fully extended across my constants. When you're writing the radical, I want you to make sure that you fully extend across all the numbers that are to be included under the radical. So here, this should actually be over the a, and this should be over the b, and the same thing in this example. Okay, so these should be extended. Okay, now we have this example, radical 72, and we want to simplify this radical. So the first thing that we're going to do is we are going to come to the side and we're going to look at our factor pairs of 72. So I have 1 and 72, 2 and 36, okay, 3, 7 and 2 is 9, 3 and 20, so that's 6, 24, 4 does not go, 5, 6, 7, 8, and 9, and wait, am I missing? No. Okay, so now we have our factor pairs of 72. Now, here what we're going to do is we're going to look for the factor pair that has a perfect square root in it. Okay, so I'm going to eliminate the ones that do not have perfect squares in them. 1 and 72 I can eliminate. 3 and 24 I can eliminate. Now, 2 and 36, 36 is a perfect square, and 9 is a perfect square. So we have two options. The option that we want to choose is the factor pair that has the greatest perfect square. So in this case, we want to choose 2 and 36 as our factor pair. All right, and so what I'm going to do is I'm going to bring my radical back, and I'm going to replace 72 with the factor pair that we chose, which is 2 times 36. And now, using my product property of radicals, I can separate these two into separate radicals. So I'm going to have the radical of 2 times the radical of 36. Now we know 2 is not a perfect square, so there's nothing that we can do with the square root of 2, but we do know that the square root of 36 is 6. So next we can write the square root of 2 times 6. Now here we cannot do anything else, but what I want to point out is that whenever we are simplifying square roots or simplifying radicals, when you write your final answer after everything is simplified and you can no longer take any more square roots, you want to write your constant first. So the 6 goes in front of the radical 2 as such. And we do that because if I were to write this 6, if I were to write my final answer as square root of 2 times 6, and I didn't put this multiplication symbol in between here, if I extended my radical, I would think that the 6 is under the radical, and we don't want to get confused by that. We want the 6 to be clearly recognized as a constant. Okay, and so my final answer would be 6 radical 2. Now, let's look at the second example. We have, we want to find the square root of 0.25. Now, we don't like to deal with radicals under the decimals under the radical. So what I'm going to do first is I'm going to change this to a fraction. Remember, this is the 5 is in the hundredths place. So we can rewrite this as the radical of 25 over 100. And now by my quotient property of radicals, I know that I can separate this into two separate radicals. So I'm going to have the radical 25 divided by radical 100. And we know that radical 25 is 5. And radical 100, or the square root of 100, is 10. And so we can simplify this to 5 over 10 simplifies to 1/2. Now, one thing that I want to go back and say, whenever we have the, whenever we take the square root of a number, remember that we have two options. We have its positive square root, and we also have negative. So for example, when we take the square root of 25, remember that we're looking for a number times itself that gives us 25, and we know that to be 5. So positive 5 times positive 5 gives us square root, gives us 25, and also negative 5 times negative 5 gives us 25. Okay, so here when we take the square root of 0.25, the square root is actually going to be plus or minus 1/2. So we need to put that plus and minus in the front. Now, let's take a look at how we solve quadratics that involve square roots. Now, looking at this, we know this to be the form of the quadratic. It's ax squared plus bx plus c. Here, our b is 0, so we just have ax squared minus c. All right, so our equation is 2x squared minus 8 equal to 0. Now, what we're going to do is we're going to solve this exactly like we would solve a linear equation. We want to isolate the variable x by having the variable on one side and a constant on the other. In order to do that, remember, we're going to use all of our opposite operations. So if I have 2x squared minus 8 equal to 0, in order to get rid of the negative 8, I'm going to add 8 to both sides. And so I'm left with 2x squared equal to 8. And now to get rid of this 2, I'm going to divide by 2. And so I'm left with x squared equal to 4. And now, what I want to point out is here, we're used to, when we dealt with linear equations, once we divided, or we got to our last step, we were left with x equal, or variable equal to a constant, where the power on the variable was 1. Here we're going to have an extra step where now we see that we're left with x squared equal to a constant, or a variable squared equal to a constant. And what I want to point out is that in order to get our variable to a power of 1, if we have squared, we want to take the square root. So x squared, squaring something and taking the square root of something are inverse operations, and when we get to functions, they'll be inverse functions of each other. Okay, and so in order to get x, we want to take the square root of both sides. So we're going to take the square root of x squared, and we're going to take the square root of 4. So remember, the square root of x squared is just x, and the square root of 4 is 2, but we want to take the positive and the negative. So we're going to have x is equal to plus or minus 2. Okay, now let's look at another example. Here we have 3 times the quantity of x minus 5 being squared equal to 18. And we want to find what x is. The first thing I'm going to do is I'm going to divide by 3 to start to isolate my variable. So these 3's are going to cancel, and I'm left with x minus 5 squared equal to 18 divided by 3 is 6. Now, I need to get rid of this square root first. Don't make the mistake of trying to add 5 first. First, I need to get rid of this square, and then I will deal with the minus 5. So the first thing we're going to do is we're going to take the square root of x minus 5 squared and the square root of 6. Now, remember, as I just mentioned, square and square roots are the inverse operations of each other, so they cancel each other out. So this square root is going to cancel out the square, and we're just going to be left with whatever is in the parentheses, which in this case is x minus 5. So we're going to have x minus 5 equal to plus or minus the square root of 6. We cannot take the square root of 6, and there's no perfect square that divides into 6, so we just leave it as the square root of 6. Okay, and so the last step that I need to do, because I need to get x by itself, is I need to add 5 to each side. And so I'm going to put the plus 5 over here. Now, whenever you have a situation as this, what you want to do is you want to put the constant first. So 5 plus or minus radical 6. You can always put the constant first, and then you can leave it as plus or minus, or you can separate it into 2 answers. So this plus or minus tells me that one of my solutions is going to be 5 plus radical 6, and one of my solutions will be 5 minus radical 6. Okay, so anytime we're solving these equations with radicals, you're going to have 2 solutions. You're going to have because of the plus or minus. Okay, let's take a look at one last example. Okay, so we have 2 times the quantity of x minus 3 squared equals negative 32. So again, the first thing we're going to do is we're going to divide by 2. We want to start to isolate that variable x. So we get x minus 3 squared equal to negative 16. Now, just looking at this step right here, or our resulting equation, we get x minus 3, the quantity of x minus 3 squared equal to negative 16. What this is asking me is, what number x, or what number when I subtract 3 from it and square it will give me negative 16? Now, we know that when we square a number times itself, even if the number is negative, we get a negative times a negative is a positive. So therefore, we can never square a number and get a negative answer. So therefore, this solution, or this statement, is never going to be true. And so we know that in this case, we have no solution, because we can never find a number that when you square it, it gives us negative 16. Okay? And so today we've looked at how to solve quadratic equations that involve square roots. And that is the end of today's lesson.